All right, we are live. Hello, everybody. Good morning, good afternoon, good evening, whenever you are. We are starting in a few minutes. You can give me a sign on the chat if you are hearing me well, if you are seeing me well. Just a friendly reminder, today's topic is Amazon Kinesis data streams. Hi, Flashpoint. Okay, so I think we can do a little bit of warm-up like we usually do with the series. Just a friendly reminder what we are doing here. So far we covered 3 services from the, you may say that from the family of services called AWS Messaging Services. Amazon SNS, Amazon SQS, and Amazon Message Queue, which is the fully managed version of Active MQ, Apache Active MQ. Today's topic is Kinesis data streams. In the next Tuesday, we will cover Event Bridge. In 2 weeks, we will talk about managed streaming for Kafka, which is the managed version of Apache Kafka on AWS. And then we need to cover last 4 services: IoT Message Broker, AppSync, Pinpoint, and a subset of the Amazon Kinesis video streams, which can be used as a messaging service. I mean signaling channels, which are covering the WebRTC part of the protocol related to data channel and data exchange. So this is the schedule for next streams. I think that the order will be as on the slide. Maybe last 2 points will be reversed, but more or less we are having the full schedule. So it means that we are almost in the middle. We are missing 2 episodes from being beyond the middle point. And yeah, my goal with this series is to do a live stream format in order to have your active participation. All the videos, all the meetings are deep dives into the messaging services, and I start from 0 and we are ending in with the even more advanced topics covered. I would like to highlight the proper use case and differences between those services, and today we will focus a significant part of the best practices in order to understand the differences between the past 3 services and today's theme. Additionally, I challenge myself to show you at least one thing you didn't know in the first that you didn't know it existed in the first place regarding this particular service. So without further ado, let's start with today's hero, Amazon Kinesis data streams, or KDS for short, which is basically a service for collecting streaming data at scale for real-time analytics. It's a mouthful name and mouthful tagline, but what does it really mean? As I said, KDS or Kinesis data streams, it's basically a durable real-time data streaming service. It's also scalable in a way that you can count on the auto-scaling. However, you will need some semi-manual intervention in order to scale it properly. We'll talk about this in the operations section. More or less, the main benefits for the KDS are real-time performance, durability, security, elasticity, and low cost when it comes to the total cost of ownership comparison. Mostly because it's a fully managed service, so you can actually benefit from having the least amount of money spent on the operations, as you probably would have to spend a lot of money in order to have such service in such scale maintained on your own. as I said, it is designed to capture gigabytes of data per second from many sources like click streams and streams of events that are coming from your websites, database event streams and change data capture, financial transactions including stocks, stock prices, tick prices, and so on and so on. All kinds of feeds like social media feeds, crawlers, and so on. Additionally, you can stream logs, which are both click streams, operational logs, and IT related information. And last but not least, it handles pretty well the location tracking events or any kind of events that are coming, for example, from the IoT fleet, so Internet of Things. All those things can be handled reliably with KDS. As usually do, I split the presentation into 3 parts. And the first part, we'll talk about architecture. How does it work? What are the building blocks? What are the integrations and the use cases with the examples in the industry? In the second part, we will talk about operational things like high availability, how to scale properly the streams, how the pricing looks like, and how to achieve the secure communication with your streams. And in the third part, we will basically discuss how to choose between 3 different services, actually 4 different services, so KDS and SNS, SQS, and MQ. And we will discuss in details the main difference between standard and enhanced fan-out consumers, because those 2 different types of consumers are having different capabilities, and it's really important to understand the differences between in order to use the service effectively. So let's start with a disclaimer, as usually. Kinesis data streams, it's not an open source technology, so yeah, we have AWS documentation, but outside of the documented parts, rest can be a speculation or an educated guess. So you need to bear that in mind. However, I think that if you look into the Rainvet videos that are covering Kinesis data streams and Kinesis Firehose and any services from the Kinesis family, they are pretty well described and covered when it comes to the internals even, and how to handle those intrinsic details and nitty-gritty details. So if you are interested in looking more into insights of Kinesis, I strongly recommend Rainvet videos, especially from 2018, where there was a few videos that are covering Kinesis data streams, especially in a very detailed and low-level way. So let's talk about architecture. How does it work on the high level? It's basically a screen from their main page when they are explaining on from a 10,000 feet view what are the building blocks and elements used inside the whole landscape. So first things first, we need to have data that are produced by our input sources. So like capturing and sending this data to Amazon Kinesis data streams is the whole purpose of existence of this service. Then KDS ingests and stores this data for processing. And those 2 elements are important because you may treat this as just an ingestion service, but the truth is that thanks to the durable storage and ability to use multiple consumers based on the shards, you are able to replay events from a immutable and durable transaction log. So we can treat Kinesis as a transaction log per se. Additionally, it integrates with other services on the AWS, like Kinesis Data Analytics, any consumers on Amazon EC2, on the Fargate, and last but not least, AWS Lambda, which gives you a tremendous advantage when it comes to the consumption. And we will talk about this later when I will explain the differences between KCL, KPL, and why Lambda is very, very useful here. Your goal is to actually build an application that will consume streams in a real-time manner in order to have the stream processing properly handled. Additionally, you can connect to Apache Spark, which is hosted on Amazon EMR, Elastic MapReduce. And if you have such cluster, you can actually leverage the streaming data and the ability of streaming capabilities for Apache Spark. And then, last but not least, somebody needs to consume this data in order to visualize that, to process that, to store it somewhere else. That's why we are integrating with the other parts, for example, BI tools or storages. So on a high level, it looks really promising and like a very basic service. But if you look closer on the building blocks, it's actually more interesting. So first things first, we've got 4 different entities that needs to be described, and which are visible on this diagram. First things first, we've got producers, then we've got Kinesis stream itself. Inside Kinesis stream, we've got shards, which is the third and probably the most important building block. And last but not least, we've got consumers. So those consumers are also important in order to understand the behavior, how to actually introduce your business logic for consuming and processing the data. In this example, you are seeing that those consumers are located on the EC2 instances. That's not required. That's not the only case. You can have Kinesis Data Analytics, as I said earlier, or AWS Lambda or Fargate. So anything that supports a custom logic. So let's start by attacking all those definitions one by one. So first, start with the data producer. As you may imagine, it is an application that basically creates those data and emits them to a stream. Data producers are assigning partition keys to those records, and we will talk about partition keys in a moment in details. But basically, a partition key can be understood like a way to shard the ingested data for your data stream. So it's a way for splitting the amount of data between multiple processing units. When it comes to the data consumer, it's basically an application that retrieves data from all shards in the stream that are generated, and most data consumers are receiving most recent data, and they are handling those data in a real-time analytics and streaming fashion. However, you can actually have totally different consumption logic implemented that, for example, replace all events that are stored inside Kinesis data stream since the retention time, or you can actually resume the processing from a point when you would like to reanalyze some kind of subset of events that are stored inside. So you don't have to focus only on the most recent data. You've got much more options. So regarding the next building block, data stream, it's basically a logical group of shards. And there are no bounds how many shards you can have within one stream. And also one additional element related to the stream is the retention time. By default, the data will be retained for 24 hours, but you can extend this retention and up to the 7 days, and obviously that it's paid extra, but still you can have multiple days of your data stored inside the stream and reprocess it later if you need it. Retention time is an attribute of a stream that can be set set when you are creating such a stream, and also when you are it can be updated later on in the process. So it doesn't have to be assigned forever to a stream. So you can extend and lower down the retention. The most important thing that you need to remember regarding retention and changing the retention time is that if you are having an existing data inside your stream and you change the retention time, it will not affect the existing data, just the new ones. So bear that in mind, because that may surprise you in a moment that you will not expect that. Speaking about streams, all streams are consisting and they are built from shards. And shard is a base throughput unit of KDS. Shard is basically an append-only log and unit of streaming capabilities. It's basically an ordered sequence of records ordered by the arrival time. One shard can ingest either 1000 records per second or 1 megabyte per second. If you would like to have more throughput, you need to add your shards to a stream. If you would like to reduce the throughput because you don't need it, you need to remove shards. The whole process is called resharding and needs to be done, needs to be invoked on your semi-automatically. You are invoking this process in order to scale up or scale down, but the whole logic underneath is happening automatically. We'll discuss this later. And last but not least, you are monitoring the metrics inside Amazon CloudWatch. So you have metrics per stream, but also you can have metrics per shard. And that's actually reminds you that shards are throughput units for Kinesis data streams. So we have streams that are consisting from multiple shards, and each of the shard is append-only log that has order by arrival time. So far so good. Let's talk about other building blocks. Data record is basically a unit of data stored inside data stream. Record is built from sequence number, partition key, and data blob. Data blob represents payload, which producer created and added to the stream, and maximum size of data blob is 1 megabyte after base 64 encoding. And that's a very important thing to remember, because if you will not remember that, you may end up in a situation that your payload is actually less than megabyte, but after encoding in base 64, you will observe sizes bigger than 1 megabyte, and you will see that they will not fit to a stream. So bear that in mind. I briefly talked about partition key, but now it's time to investigate it more deeply. It is typically a meaningful identifier, and you can use user ID, any kind of identifier, timestamps, and so on and so on. And it is specified by you when you are producing the data via data producer, and it needs to be inserted to a stream together with the data. It's useful for consumers, as they can use the partition key to replay or build history associated with this particular partition key. So when you want to store history of your entity, it is useful to use partition key as your entity ID. And in this case, you will be able to replay all events that are happening for a given entity on the consumer side. And that will allow you to easily consume the data from the shards. Also, partition keys are split between the multiple shards. So if you would like to have ability to consume multiple 1 megabytes increment per second, you need to have multiple shards and multiple partition keys. Partition keys are also used to segregate and route data records to different shards of streams, and that's basically an example that I explained in a second ago. So if you have two shards inside a stream, let's call it shard 1 and shard 2, you can configure data producer to use two different partition keys, and all records with key A will be added to shard 1, and all data record with key B will be added to shard 2. And then on the consumer side, you can independently consume shard 1 and 2 via with the different partition keys. Additionally, data record consists also of a sequence number, and it's basically a monotonically growing ID that it's assigned by the Amazon KDS when a data producer calls either put record or put records API when we are inserting data to a stream. So inside one partition key, you can use this approximation that generally those sequence numbers are increasing over time. It's not entirely guaranteed, so you can see sequence numbers that may be the same for the different records, but it shouldn't happen so frequently. The whole point is that the longer time distance is between individual put records calls, the longer the gap between sequence numbers will be. So you can treat that as a timestamp and monotonically growing one. When it comes to integrations for Kinesis data streams, you can actually have following integrations. So for putting the data into streams, you've got following options. Either you can use something called Amazon Kinesis Data Generator, which is the open source project created by AWS to simulate and to create useful demos for Kinesis. This is a very useful thing because, for example, if you would like to generate such amount of data on your own, you need to create such generator by hand. In this case, you can leverage the data generator instead. But that's basically a mock/test tool. The more real-world examples are using either Data Streams API, which is the regular AWS API available for a service. You can use Amazon Kinesis Producer Library, which is shorted by KPL, and KPL is written in Java. And if you would like to use multiple languages, you can use also multiple languages, but you need to bear in mind that they will require to set up something called a multi-language daemon inside your application. So you will need to have Java on the producer side. And last but not least, you've got Amazon Kinesis Agent, which is the OS level service that you are installing on your either Windows or Linux machine, and you are just pointing it to log files to places when your data arrives, and it periodically reads the file and sends the deltas to Kinesis data streams. When it comes to stream processing, you get ability to directly integrate with Kinesis Data Firehose, which is another Kinesis-based service, which is used for putting data into Amazon S3, to Amazon Redshift, to Amazon Elasticsearch service. So all those databases and AWS-based storages. You've got also ability to process data with the Amazon Kinesis Data Analytics, which is the fully managed version of Apache Flink. If you never heard about Apache Flink, I strongly encourage you to look up it, because it's another streaming / data processing framework from the Apache incubator, and it's often claimed as a successor of Apache Spark. Then you've got ability to integrate directly with AWS Lambda, and this integration is awesome because you can use any language you want and you don't have to rely on Java, which is the case for Amazon Kinesis client library. And the story is similar like with the KPL. In order to use multiple languages, as the Kinesis client library is written originally in Java, in order to use multiple languages, you need to set up a multi-language daemon on your machine. And having this daemon set up, you can connect from any language you want, from Python, from Node.js, and so on. But still, it will require Java on your machine anyway. With Lambda, you are not constrained by that at all. You can use any language supported by Lambda. You will receive a JSON-like event which will contain the payload, the sequence number, and partition key inside. Last two integrations are related with the different services. So Amazon Kinesis connector library is a way to connect multiple databases, multiple storages directly with Amazon Kinesis. And if you'd like to write your own integration, you need to do it in Java again. But it's very helpful. It's actually very similar to Kafka Connect or something like this. And last but not least, you've got integration with Amazon Kinesis, data streams with Storm, Apache Storm, because you've got a dedicated spout. If you haven't heard about Apache Storm, it's basically one of the first real-time processing engines, and spouts are just the entities that are available inside this framework for data processing. So Kinesis has a dedicated spout in order to integrate with Apache Storm. Speaking about integrations and use cases, it's always worth mentioning what are the different use cases when it comes to how to use the Amazon KDS. And use cases are really, really diverse. So you can start with monitoring communications and metrics in the microservice architectures. You can collect a stream of the scraped data and update your data storages in real time based on that data, like Zillow does. You can collect stream of financial data and update your databases and storages. You can collect click streams and execute analytics on top of that. Great example would be to collect points of sales data streams or anything related to retail and processing retail data. So all those elements are really, really helpful when it comes to the data ingestion use cases, but also when it comes to the data analytics use cases. So those two things are really, really helpful to be handled on the Amazon KDS side. And that concludes the part one. So if you have any questions, please let me know in the chat. Otherwise, we'll continue. So I don't see any questions so far. Let's go further. So let's talk about operations, and first things first, how to achieve high availability with KDS. That's not something obvious on the first sight, and it's buried down in the documentation even, but mostly because KDS is a fully managed service, so it has built-in high availability. The only drawback currently is that you need to take care about two elements. You need to take care about recovery for your producers and consumers, and you need to think about availability in the regional, when it comes to the regional failures, because streams are entities that are bound to a single region. So if you are expecting to have multi-regional availability, you need to work on that on your own. Additionally, all those recovery strategies and disaster recovery strategies for producers and consumers are really important, because KDS it's in itself as a stream capability and reliability, it is very resilient, but the overall resiliency for the end-to-end system will be affected by the reliability of your producer and consumer business logic. So you need to be careful when it comes to the leveraging KCL and KPL. And actually, if you are using KCL or KPL, you are pretty much handling everything what's needed. You need to be careful if you like to set it and use it on your own, because it will require a significant development in order to handle this properly. So the better way and better choice is to leverage KCL and KPL. Another topic related to operations is scalability. And in this case, as I said, KDS is a fully managed service. The only part that we need to be bothered by is the process of adjusting number of shards that are available in streams. And this whole process is called resharding. And there are two types of resharding operations. And they are happening pairwise. So basically, either you are doing a shard split, so you are splitting one parent shard into two children shards, or you are merging shards, so you are taking two parent shards and you are having as a result one child. Splitting is basically focused on the increasing shards count, so it basically has a higher cost because we pay for all those shards, but we have more throughput. If we merge shards, you are decreasing the overall count, and that leads to lower costs but also lower throughput. As I said, we start often with the parent shards, and the result of the resharding operations are referred as children shards. After each operation, shards will be inactive for a moment, and you need to have an implementation. Your implementation needs to be aware of that fact. So you need to handle this situation in your application logic. So if you are doing dynamic resharding operations, you need to be prepared that some shards may not be active for when it comes to the polling for the data or consumption. And those operations, splits and merges, can be done pairwise and can be done manually, but you can have also an additional API called update shard count, when you are just setting up the expected number of shards, and the whole process of splitting and merging will be handled by the Kinesis itself. The one thing that you need to remember about update shard count is that it may produce many shards and more shards than you expected. So for example, if you would like to have updated shard count from 3 to 5, you will see that the shard count will have 3, 6, and then 5, because we need to split and then merge in order to achieve the fifth shard. So it's useful to scale with the in the even numbers, because as I said, the operations are pairwise, so it will be more beneficial to actually scale into the even numbers, because it will require less operations when it comes to splits and merges. And regarding this pairwise operations, you cannot split more than 2 shards in a single operation, and the same goes with merge. So you cannot merge more than 2 shards in a single operation. That's what I mean by pairwise. And you need to remember that, because that will affect the inactive period and also how much shards will be generated in the process as a additional side effect of the resharding. I already talked a little bit about the pricing, but more or less it is a pay-as-you-go model. And we are paying for two things for sure. We are paying for shard hours. So every single hour that our shard is active, and one shard is able to handle 1 megabyte per second for ingress and 2 megabyte per second for egress. And for every single hour that shard is active, we're paying. But also we pay for the put payload units, and one unit is equal to 25 kilobytes, and you are paying in 1 million of units. So if you have two shards and you are entering 50 kilobytes per second, you will pay a little bit more than you will have two shards and, for example, 25 kilobytes per second, because the put operations are also counting into the overall cost. Additionally, you can pay for the optional factors like extended retention. So everything above 1 day, 24 hours, it's paid extra. And if you enabled enhanced fan out consumers, you will pay out for retrievals and per consumer shard hours as well. And why, you will see in the last part of the presentation, when we will cover in details the differences between standard consumers and enhanced fan out consumers. Kinesis Data Streams has a dedicated calculator, which is available here. So you can actually specify the amount of records that you will be sending, for example, per minute. Let's go with the 50 records per minute, and average record size is for example, 30 kilobytes, and we will use not so many so yeah, here we are specifying the number of standard consumers, and here we are specifying number of fan out consumers. So fan out consumers will be 0, and we will have 5 consumers when it comes to the standard ones. We will not pay extra for the data retention, and when it comes to the Kinesis Data Streams estimate, we will pay almost exactly $11 per month. If we will have, for example, 100 records per second, and records will be small, like 5 kilobytes, and we will have 10 consumers, we will pay almost $37 per month. So this calculator is pretty handy when it comes to the evaluating how much you will spend on the KDS, and bear that in mind that not all services are available in the new pricing calculator. So I encourage you to investigate it. The website is calculator.aws. And let's go back to the presentation. So we talked about pricing. Now let's talk about security. AWS Amazon KDS actually supports full encryption in transit with the newest SSL and TLS versions. Additionally, it supports the authentication via the signature version 4 process, so the same one that we have with the AWS API. So we are pretty much secured when it comes to the in-transit, when it comes to the man in the middle attacks, and so on and so on. The same goes with the server-side encryption, so it supports fully integration with AWS KMS, and you can either have AWS or customer managed keys in order to encrypt your data at rest. So it's really, really great that we have the both at rest and in transit encryption. Additionally, Kinesis has multiple compliance and regulatory confirmations like HIPAA and so on and so on. Keep in mind that server-side encryption encrypts the incoming data after encryption is enabled. So any pre-existing data remain unencrypted after the server-side encryption is enabled. Only the newest data will be encrypted. And that concludes the part related with operations. So we are going to a part 3, best practices. But do you have any questions so far? If not, let's proceed with the last part. So here I would like to focus on the best practices in terms of the comparison, how to use and when to use those 4 services. First things first, comparison between KDS and SNS, probably the easiest one because the services have very different characteristics. If you need notifications and ability to send push notifications to multiple subscribers, definitely SNS should be your option. If you would like to have an ability to reply events and, for example, have multiple consumers that are replaying those durably stored events, then it's definitely a case for Amazon Kinesis data streams. When it comes to the comparison between KDS and SQS, it's really similar. If you need a queue, so you have a single type of consumers, you should use SQS. If you have multiple consumers, then KDS is the way to go. So if you are consuming a single type, if you have a single type of a consumer, SQS will be a way to go. If you have multiple type of consumers that are competing over one queue, that's probably not a good idea. So instead, a Kinesis data streams may be a better choice. Comparing MQ, Apache Active MQ, a managed version, so-called Amazon MQ, and KDS is also simple. So if you have an existing message broker already in place, Amazon MQ is the service that you should use. Otherwise, you should either consider SQS, SNS, or Kinesis data streams. And that will conclude the best practices for choosing between those 4 services, one after another. And I would like to show you here a difference between standard and enhanced fan-out consumers. And this is really crucial when it comes to the understanding how Kinesis works, KDS works. So first things first, we've got 2 types of consumers, and by default, you are using the standard consumers. They are often called in documentation as shared throughput consumers. Why? You will see in a moment. Then you've got alternative type of the consumer called enhanced fan-out consumer, which is in documentation called a dedicated throughput. What is the difference between standard and enhanced fan-out consumer? So standard consumers can handle 1 megabytes of ingest and ingress and 2 megabytes per second for egress. But this 2 megabytes per second for egress are shared between multiple consumers. So if you are having multiple consumers on the other side of the Kinesis data streams, the whole throughput will be shared between them. So if you've got one shard, the throughput for that given shard will be shared between those consumers. If you would like to have a single consumer that have full 2 megabytes per second throughput, you need to have either a single consumer or you need to provision a dedicated throughput, so enhanced fan-out consumer, because this will give you the dedicated full speed 2 megabytes per second throughput. So the main goal of using enhanced fan-out consumers is to improve read parallelism and reduce the latency, but you will pay much more up for that, because you are paying for hourly charges per consumer shard per hour and per gigabyte of data that are retrieved from enhanced fanout consumer. And also there is a limit that you can register up to 20 consumers per stream to use enhanced fanout. So how the consumption logic looks like in details. First, let's tackle the standard consumers. So if you have a one Kinesis data stream and you have multiple shards in it, for each shard, you are calling the get records API, and then you will receive data. One consumer application can retrieve the records from a single shard every 200 milliseconds. So it means that get records are throttled to have 5 transactions per second per shard. Additionally, it will be limited by 2 megabytes per second per shard. So when it comes to the single consumer application that is reading from a single shard, it's not a big deal because 5 transactions per second per shard and 2 megabytes per second per shard are pretty nice numbers. But the main problem appears when you have multiple consumer applications, because that will actually spread and split the 2 megabytes throughput for a given shard between all those consumers. So it means that in this case, having 5 consumer applications, we are having less or equal the 40 kilobits per second throughput. And also, each consumer application can ask just for one get records API call per second, because we are also sharing disk limit between multiple consumer applications. So that's a much more constraining situation, especially that we would like to have multiple consumers in order to increase read parallelism. You can resolve the situation by having sharding and implementing a different partition key mechanism, or you can actually reduce the amount of shards and leverage the enhanced fanout consumer. Enhanced fanout consumer is a more complicated beast. So you are actually creating a dedicated EFO pipe, and your consumer is register itself to a shard and then subscribes to a shard and receives the data up to 22 megabytes per second in a push way. If you look on a previous slide, you will see that the get records API calls are basically appalling calls. So you need to invoke the get records data, and you need to poll it into a proper with a proper delay in order to not exceed the throttling and limitations. When it comes to the fanout consumers, we are actually leveraging a push. So thanks to the subscription to a given shard and dedicated pipe, we can both have ability to receive data with the lowest possible latency, but also we have a dedicated line of 2 megabytes per second for a single consumer. How the push capability work? It uses basically HTTP2, so up to 5-minute connections, and thanks to those long-living connections, you can push data to a consumer after the subscription is ready. So it works like as follows. The data producer sends data to a data stream. It is based on the partition keys. It is split between the shards. It is persisted. And then if the subscription from a consumer application is active, you can actually receive the data in a push manner to a given consumer. And you don't have to be bothered, and you need to worry about the limits that are imposed on you in the first examples with standard consumer, because you don't have to split the throughput between multiple consumers, and also you don't have to share the limit for throttling, so 5 get records API calls per second. And you may ask, okay, so we've got two different types of consumers, so when we should use which type of consumer? So it is useful to use standard consumers when the total number of consuming application is low, so less than 3 consuming applications, and custom consumers are not latency sensitive because thanks to a polling, you will be limited by this polling mechanism when it comes to latency. Additionally, standard consumers are also cheaper, so if you would like to minimize costs, that would be a way to go. If you would like to have a low latency, or you would like to have a full throughput capability for your shards, then it will be necessary to use fan-out consumers. And this is very, very useful to have it in case you would like to have multiple consumer applications for the same data stream. A default limit is the 5 registered consuming applications. You can raise this based on the limit, a quota limit that you can raise with the support. And also if you are requiring to have low latency for data processing. And with the fan-out consumers, enhanced fan-out consumers, the messages are typically delivered to the consumer application in less than 70 milliseconds. So it's pretty interesting, very low level latency, but still you will require a little bit of extra money to spend in order to have that low level latency. So that's basically everything what I prepared for you. So now it's time for Q&A session. So I hope you've got some questions. In the meantime, I will remind you that we will have an event bridge presentation next week on Tuesday, hopefully on Tuesday. And in 2 weeks from now, we'll have managed streaming for Kafka, so manage Apache Kafka on AWS. I don't see any questions so far, so if you don't have any, I think we can conclude today's session. Yeah, thanks Flashpoint as well. So if there are no questions, that's everything what I prepared for today. Thanks for being here. Thank you for participation, and see you next week. Goodbye.